So a little review of what we've done so far. We've done long division, synthetic division, and then we've learned the remainder theorem, the factor theorem, and the factor property. So how do those come into play if you want to factor this completely? Well, if we want to factor this completely, because it's an x cubed, it is possible to have up to 3 factors. We can't have more than 3 factors because if this is going to have an x, an x, and an x, when that's all multiplied together, that will give us an x cubed. In fact, I'm going to know that one of these has to be a 3x. So when I do 3x times x, I would get 3x cubed. I also know, and this is the factor property, since my last number, my constant term is a 2, that these last numbers have to equal 2 when they're multiplied together. So I'm not going to check if x plus 5 is a factor because I already know it won't be. So what we need to do, we need to find one factor, then use synthetic division to write a division statement. And we've seen this already, that if something is a factor, when we write the division statement, we are writing a factored form of it already. So the question is, what should I try? What would be some good possible factors? Do you see that if this is a 2, you could have x plus 1 or x minus 1. You could also have x plus 2 or x minus 2. But there will be no other x plus or minus ones that would work because if it's going to equal 2 as the last one, it has to be one of these. There's also the possibility of the 3x plus 1 and 3x plus 2, but we're not going to worry about that one because these ones we can use synthetic division with. The 3x plus something, we would have to use long division with. So you have options. Some people like to use, how do you find out if something is a factor? Either the remainder theorem or synthetic division. Okay? The ones with 1 are the easiest to check with the remainder theorem. So usually people start with that. And above here, we're going to do this again. Let p of x equal all of this. So we can check what happens if I plug in 1. Does it work? P of 1 would be 3 minus 4 minus 5 plus 2. What does that equal? Negative 4. That tells us that which one is not a factor. If I plug in 1, is that checking the x minus 1 or the x plus 1? It's checking the minus 1. X minus 1 is not a factor. If I check p of minus 1, again, I think the remainder theorem is still okay. Once I check x plus 2 and x minus 2, I might want to just start with synthetic division. Okay, but p of minus 1 is still pretty easy. If you plug in minus 1 and negative 1 cubed, this will be negative 3 minus 4 plus 5 plus 2, which is equal to 0. That tells us x plus 1 is a factor. The thing that can get your brain messed up is, like, you see how you keep switching between positives and negatives? Can you see your brain getting mixed up there a little bit? Okay? Now, If x plus 1 is a factor, we found one, we can use synthetic division. Set up my synthetic division. My original one is 3, -4, -5, 2. It's in the right order. Did I write it in the right order? Or did I mess it up? Here we go. Double check it. Was it -4 next? Yes, it's good. And if we're checking to divide by x plus 1, what number do we write on the outside? Minus 1. Bring this number down. 3, multiply, add, multiply, add, multiply, add, and this is what we wanted to see. We wanted to see that remainder of 0. We can now write our division statement. P of x equals, the divisor is x plus 1. The quotient would be 3x squared minus 7x plus 2 with no remainder. So our division statement is that Dairy Queen thing, dq plus r. We have no remainder, so this is a starting of factoring. And once you get down to having just an x squared, now you can go to your regular factoring. How do you factor this? It would have to be 3x and x. A 2 is going to need to be 2 and 1. I'm going to think about my outside and inside need to be -7. So I'm going to put 2 here to get 6 and 1 here. To get a -7, it would be -6 and -1. I quickly multiply it out to check everything works. And this is factored fully. What would happen if we had started with an x to the 4 equation? Maybe we should do, yeah, let's do, I think I've got an x to the 4 one here somewhere. Oh, yeah. Okay, first of all, I'll give you the questions that you can circle. They are 5, 9, 10b, and 11. And I think we'll actually do one from your homework. We're going to do 11b together. Oh, I like 11b. I like 11b because I see a shortcut, but I'll teach you the shortcut. So if you turn to 11b, let's do this one together. First of all, can you see that with the 4 at the end, your possible factors those are your possible factors. There's 6 of them that could work. Okay? I'm going to, just like before, let P of x equal all of this. The 1s are the easiest ones to check. In fact, you probably can see some mental math really easily. If you plug in 1, will it equal 0? If I plug in 1, I'd have 1 minus 5 plus 4. Does that equal 0? Yes. So, x minus 1 is a factor. And if I write out the long division, this is a good one for long division because you would have a 1 here. We have no x cubed, so you have to put a 0. Then we have negative 5x squared, but we have no x's, so we have to put a 0. And then a 4. Dividing by x minus 1 would put a 1 out there. Bring down the 1. 1, add, multiply, add, multiply, add, multiply. And sure enough, we get our remainder of 0. If I write my division statement, x minus 1, and since we started with an x to the 4, does it make sense that then this one will be an x cubed? So we have 1x cubed plus 1x squared minus 4x's minus 4 with no remainder. And the reason I wanted to do this one is because once you've factored it once, we still have an x cubed in here. So we have to do this process again. Okay? We've used up p of x, so we need to just check, choose another letter. What do you want to use? H of x? R of x?
No, H.
H. So let h of x equal all of this. And again, what are the possible factors? Same thing. X plus 1, x minus 1, 2, 4. So we would have to check. This time, can you see that if you plug in 1, it would be 1 plus 1 minus 4 minus 4. 1 won't work. But let's try plugging in negative 1. Negative 1 cubed would be negative 1. Negative 1 squared would be positive 1. Negative 1 times negative 4 would be positive 4. Equals 0. So, x plus 1 is a factor. It's a factor of h of x. It would also be a factor of p of x. As far as writing out or doing our synthetic division here, now I'm going to use 1, 1, negative 4, negative 4, negative 1 outside, because I'm doing the synthetic division for h of x. I can bring down my 1, multiply, add, multiply, add, multiply, add. And I could rewrite, I'll just do it quickly, p of x, which we already had x minus 1 as a factor. We now have x plus 1 as a factor, and are left with x squared plus 0x's minus 4. And that x squared part you could factor as x plus 2, x minus 2 to be done completely.